Welcome to Key Skill 4. We're going to be looking at distinct real roots, how to find them. For example, find the range of values of k for which kx squared plus 2kx plus 3 equals to 0. The first thing you need to be able to do is we have to look at the equation and identify the a, b, and c. The a will be in front of the x squared. The b will be in front of the x. And the c will just be a number or a letter on its own. Now, for two real roots, you need to know the equation. So it will be b squared minus 4 times a times c. So it will be 3. And you want to have all of that for two real roots bigger than 0. So you need to remember that. This is also called, you may have heard the word, the discriminant. Okay, so we're going to substitute these in. So b is 2k. That needs to be squared minus 4 times a is k times c is 3. And you want that one bigger than 0. 2k squared is 4k squared. Don't forget you need to square the 2 and the 4. 4 times k times 3 is minus 12k bigger than 0. We're going to factorize that now. I can take outside 4k, and that will leave me with k minus 3 bigger than 0. So for now, you're just going to imagine it was equal to 0. And equal to 0 here, if you imagine that that was an equal to 0, so that we can draw the graph. So the two solutions would be k minus 3 equal to 0, k equals to 3, and 4k equals to 0, or k equals to 0 divided by 4, 0. We're going to use that information to draw a small little rough sketch. We're going to put our roots here on 0 and on k equals to 1, 2, 3. This is a positive k squared, so it will be a smiley face graph. So that's 0, that's 3, that's x. Oh, so it's not x, that's k. Now, we have this one bigger than 0. So for bigger than 0, you are going to want to shade above. So you're going to shade here and here. Now, that will give you two solutions. This solution will be k less than 0, because we're going to the left. And this one will be k bigger than 0. Sorry, k bigger than 3, because this one's going to the right. So if your equation is bigger than 0, you want to shade everything that is above. So bigger than 0, shade above. And that question is finished. Let's have a look at the second one. The a in front of the x squared, a is k. B is in front of what's in front of the x, the coefficient of the x, k plus 1, and c is what's along. So two real roots, we're going to substitute that into the formula b squared minus 4ac bigger than 0. B squared is k plus 1 squared minus 4 times a, which is k, times by c, which is 1, bigger than 0. So k plus 1 squared minus 4k bigger than 0. So we're going to multiply that out. That will be k squared plus k times 1 is k, or 1k, plus k plus 1 times 1 is 1, minus 4k, bigger than 0. So it'll be k squared. I've got plus k, that's 2k, minus 4k, so minus 2k, plus 1, bigger than 0. So I want two numbers that multiply for 1 and add up for minus 2. So I'm going to have k minus 1, k minus 1, bigger than 0. That's going to be k minus 1 squared, bigger than 0. So I'm going to make a little rough graph here. Now my only solution will be k equals to 1, which will be here. So in this situation, because I'm shading above, everything will be shaded. So my answer will be all values of k, or k an element of R. Because you can see everything is above 0 like we need. Let's have a look at another one of these guys. Here we're going to have a is equal to 1, b is equal to k plus 2, and c is equal to minus 2. So always start by writing your formula. Minus 4 times a times c, bigger than 0. Minus 4 times 1 is minus 4, times minus 2, plus 8, bigger than 0. 2k, plus 2k, plus 4, plus 8, bigger than 0. K squared plus 2k is 4k, plus 12, bigger than 0. This one here cannot be factorized. You can try, you can use the formula, but it won't work. So again, if you complete the square, maybe be the easiest way to draw it. K plus 2 squared minus 2 squared plus 12. So k plus 2, that will be plus 8. If we imagine that was equal to 0. So if I want to draw a rough graph of that, I would need to put the line of symmetry in it at minus 2. Remember, minus 2. So that would be here. And I would put it in at plus 8. So if I went up in 2s, 2, 4, 6, 8. So the bottom would be here. So that's what it would look like. So if I had to shade above or bigger than 0, that would still be everything, all values of k. Okay? The last one is a show that question. So we have to prove that it has two real roots. So we have to prove that it's bigger than 0. So we have a is equal to p, b is equal to p plus q, and c is equal to q. So I'm going to pop them in. B plus, well, let's write the formula first. B squared minus 4ac, and I have to show, I'm required to prove, you can often see, that this is bigger than 0. First I'm going to work this out. This is b plus q squared minus 4 times a is p. Let me change that one to p plus q squared minus 4 times p times q. So I have to show that's a positive number. If I multiply this out here, that will be minus 4pq. If I multiply this out, I'm going to get p squared plus pq plus pq plus q squared. And I have minus 4pq. The pq plus pq is 2pq minus 4pq, which is going to be in total minus 2pq plus q squared. This can be factorized using this rule. You may recognize this if you're already up to date on your binomial theorem. A minus b squared is a squared minus 2ab plus b squared. I'm going to factorize this line by saying that's p minus q squared. Now here I'm finished because I can say this is bigger than 0 because any real number squared is automatically bigger than or equal to 0. So mine will be bigger than 0 as long as p is not equal to q, which would mean 0 squared. So p is not allowed to be equal to q. But any number squared will be a positive number. For example, even a negative number squared will become positive because a negative times a negative is a positive. So if you're ever required to prove that something is bigger than 0, try to write it as something, in this case p minus q, squared. And that will be enough to prove that it's bigger than 0. And if I can say that b squared minus 4ac is bigger than 0, I can automatically say that I have 2 real roots. So you take your ABC, you substitute them into the formula, and then you do the algebra required to get positive number only. So something squared or positive numbers times positive numbers, for example, that would also be okay. So you get your ABC, you substitute them into b squared minus 4ac, and you use algebra to show that everything is positive. This is a great trick to show that things are positive if you can write it as something squared. That is key stage 4 done. Stick around for the next one. Do all the questions below, and I'll see you soon. Bye for now. The team at Maths with Sophie have made a free ebook to go with this video series. We've broken the topic down into small, manageable sections. Each section has a video tutorial that you're already watching, interactive questions, and model solutions from exam questions. To claim your free ebook, you don't need to download anything, you don't need to sign up for anything. You simply click the link below and it will open in the web browser of your phone, tablet, or computer. If you enjoy using our free ebooks, make sure you check out our website because we have other ebooks on different topics.